Hey guys, today I'm going to talk about the CNN project, how to solve this project from a high level. So basically, what you need to do in this project is to um, create a model that can detect the dog breed in a picture, or if it is a picture that contains a dog or it contains a human. Um, what I really like about this project is that first, you finally you can build a model that's really powerful to detect the dog breed in the picture. This is unbelievable if you are not using a deep learning method. So by doing this, you will see the power of deep learning technology, what it enables people to do, especially in computer vision area. And the second thing I like about this project is that it tells you that no technology is perfect, and what you can do to to mitigate um, disadvantages like that. So, for example, no model can tell can predict the dog breed in the picture 100%. So what you do if it failed? What you do if you have low confidence of the dog breed? So that's engineering or product problem you need to solve, and I think it'll be it's what it's what you will need to do in a real life scenario. Okay, so I'm looking at the project overview of this in this page. Um, so it tells you what you need to do, and here it says you what you need to do to give a user a good experience if your model can't give a very accurate answer. Okay, so now these are the instructions. Let's open the GitHub repository, which I already opened here. So what I'm looking at is the README file of this project, but here it's all all about the files you need to download and the setup that you need to do. So basically, you will either use AWS to train the model, or you can train the model on your PC or on your Mac or Linux. I used AWS because I think it's faster. It's much more powerful, unless you have a very powerful graphic card. I use Mac, so I don't have, and the Mac is not good for its graphic card. So that's why I use AWS. And I think using AWS give you a real sense of what the training what the training will be like in real life scenario. So I suggest you also take that approach. I think this is relatively straightforward. So you clone the repository, um, and do the development. Um, so just following these instructions should give you a very good environment. And this is the rubric. I suggest when you do the project, I suggest that you before you submission, you check all those things to make sure that you meet all the requirements. Um, Now let's take a look at um, the notebook file. So it has 8 steps So the first step is to, of course, import the dataset, which is, I think, mostly done for you. So you just need to execute them and get a sense, what the dataset look like. And I think it already contained some of the image. Maybe not. Anyway, oh yeah, here's the picture. Oh yeah, so that's kind of like the final result um, that you're gonna see at the very end of this project. So all your work is done in this notebook file. I don't think you need to change anything outside of this notebook file. So after import the dataset, the first task you need to do is to detect human, and the way we detect human is by using what is called a hard feature-based cascade classifier. So this is pure computer vision approach, which doesn't use any machine learning at all. So basically what you need to do is you need to import the model using OpenCV library, and then read the image and use this feature to predict. Um, um, and the next step is to detect dog. The next task is to detect dog using a ResNet model, which is of course machine learning based model. And the model is already pre-trained using ImageNet dataset, which is a very popular dataset for training machine learning model for image recognition and all computer vision related problems. Yeah, so and also ResNet, if you don't know, ResNet 50 is also a very popular model. Um, it's not that powerful, but you need to consider the computing power of the machine you use, and I think ResNet 50 gives a good balance between the training time and the accuracy. So after getting a sense of what a deep learning model can do, now you need to create a CNN model to classify the dog breeds from scratch. This means that you need to decide the architecture of your model and train the model using the dataset that you imported in the first step, and see the result. So this is like a sample architecture. You don't have to make your architecture look like this exactly, but this is a very good starting point. So I suggest you follow that architecture. Yeah, and then training, and then test the model. And the step 4, which is to use already trained model to detect the dog breeds. So here it use the VGG16, which is also a kind of a popular one. And step 5 is to use so-called transfer learning to do the classification. So step 3 is to build the model from scratch. Here it doesn't use any predefined model to do that. So you decide the architecture. But step 5 is to import the bottleneck feature from a pre-trained model, and with Udacity has provided 4 pre-trained bottleneck features. And the reason we use transfer learning is that first, it's very fast compared. If you first, it's very fast. And if you want to have the same accuracy compared with building the model from scratch, because most of the job, most of the training, the hard part is done, is already pre-calculated for you, and you just need to load all those information into the memory and feed those data points to a very thin layer, which is the final layer. Yeah, so all these blocks marked with implementation means you need to fill in the code to do the task. Just follow them step by step. And finally, after you get a very accurate, not a very accurate, more accurate model, now you need to think from a high level how to use this, how to leverage this model, how to leverage the accuracy that this model can give you to design a good product. So that means if your model is only, let's say, 60% accurate, how to soft the rough edges so that the user don't feel that this is this is bad, this is not accurate, I don't like it. How do you improve the user experience? So something you can do is that if your model doesn't feel confident about the prediction it gives, you can change the wording a little bit, saying something like, oh, I guess this is a golden retriever, but it also might be something else, right? So you need to think about something like that. And also what you can do as an extension is, right now the model is executed in this notebook, but can you host your put web server in front of your model so the user can interact with the model through a web page? That'll be even better, or make it work on a mobile phone. That'll be even better. Okay, I think that's pretty much about it. Let me know if you have any questions. Thank you.